We have Module 4, Lecture 2. Control charts. So what are control charts? Control charts, well, they start to look like a run chart. So it's a quality control tool, quality improvement tool, quality management tool. It's a way that we're going to look at data over time again. But we're going to add a few more things. We have the mean in here. We're also going to add 2 more mathematically calculated lines. There are a number of different kinds of control charts to use, and what that means is we've used different ways to calculate these lines called the upper control limit and the lower control limit. And depending on what kind of data we're looking at, what kind of processes we're looking at, we'll have just a little bit different formula to look at these 2 lines, the upper control limit and the lower control limit. What these things mean is that if our process is working right, it's just between these 2 lines right here. If you put your car on cruise control, you'll notice that when you go uphill, the car might slow down a half a mile an hour or a mile an hour or 2 miles an hour. And then you're going downhill and your car is working real hard not to go over that speed limit that you've put on your cruise control, and it might creep up an extra mile or maybe an extra 2 miles an hour over, but it's not going to go more than a mile or 2 away from, mile or 2 per hour away from that original number you put in there. So if you put in, we're going to drive 60 miles an hour. Sometimes you might be driving 59 miles an hour, sometimes you might be driving 61 miles an hour, but that's close enough. There's that little variation that takes place. So we say that with the upper and lower control limits, if we're driving anywhere between 58 and 62 miles per hour, we know that this cruise control we have on this car will always do that. So it's operating within its control limits. It's working the way it's supposed to. If all of a sudden this thing speeds up to 75 miles an hour, something's wrong. It's outside the control limits. Or if we somehow drop down to 40 miles an hour, it's outside the control limits. We would expect it to always be between 58 and 62 miles an hour. When we set it on the mean, 60 miles an hour, we expect it to be between those 2 numbers. So when a process is moving along, something we're doing out there in the world is moving along just fine, there's just going to be some little variation like that. Pretty much anything we do. You're going to go for a walk. You know, part of the time you walk a little slower, a little faster. It's okay. You have about an average kind of, pace that you walk, like our running example we looked at before. We have our grocery bill for our house is about the same every week. We may have a party one time and boom, it spikes up here. Or we're on vacation for a few days and our grocery bill for the household items at least is way lower than it usually is. But most of the time it's going to be about this kind of a number. Around, it'll vary in there somewhere. So that's what this is talking about. And the upper and lower control limits say, and when we mathematically calculate the distance from the mean, we say these control limits, everything in that process should be working within those 2 lines. If it goes outside those 2 lines, then we have to take a look at that to see what's going on. This dot right here is out of control. It says, something weird happened here. All the other dots are within our control limits. It says the process is working fine. You don't need to bother with anything at all. An out of control point says that something weird happened here. So we need to do something different with this. We need to take a look and see what happened there. Examples of this. We may have a personnel policy that gets put in place because one person, one time, did some weird thing that nobody ever thought anybody would ever do. But that one person did this. And so most of the time, everybody in the organization is, kind of working along at kind of this rate, and everything's going fine. And one time, things just dip really low because somebody did something really weird that nobody ever would have imagined. Now we have a personnel policy that gets put in place that everybody has to live by for the next 85 years in the organization because one person did something weird one time. That means that this out of control thing that happened somebody dealt with that wrong. They tried to change everything because of one thing. If we have one control point like this that goes outside the limits, you just step in and do one thing about that. So with that person that did the wrong thing, you just go talk to them and straighten things out somehow. And maybe they made a mistake because they didn't have the training they needed, they didn't have the tools they needed, maybe they just made a mistake because they were just stupid that day. Who knows what happened along the way. We just deal with that one incident all on its own. You don't change everything for everybody based on that one weird little incident. So that's called special cause of variation. And we deal with those just individually. An example of that, W. Edwards Deming was a person that went to Japan after World War II. MacArthur brought Deming to help him build some radios. After World War II, MacArthur went to Japan to rebuild Japan, and he realized I have to communicate with everybody in the country. The best way to do that is going to give everybody a radio. Gee, how do we get radios to everybody? Well, we're going to have to make them and give them to everybody. How are we going to do that well? Let's bring this guy over who kind of knows about some of this stuff, how to do things well, called W. Edwards Deming. He came over and helped MacArthur get those radios out to everybody, get good ones made, get them made fast, get them out to everybody. Well, Deming then stayed in Japan to help other industries. MacArthur said, help us with some other industries around here. We have to rebuild this industry and that industry, the auto industry, the clothing industry. We have to build all these other industries. Let's help rebuild those industries. One of the people who was in a lecture that Deming was given came up after the lecture and said, hey, I have a factory that's just right down the street here a little ways, a clothing manufacturing operation. Could you just come and take a look at a problem that we're having down there? Do you have a minute to do that? And Deming said, well, yeah, we've got the afternoon free. Let me come down there with you and we'll see what that's all about. They walked down to this factory. They went up to that little catwalk around the top of the factory, looked down over the factory, a bunch of people sitting down there sewing clothes together. Deming said, well, everything looks pretty good here. You've got a bunch of people down there working well. Everything is going great. Looks like you got nice new equipment down there. What seems to be the problem? The CEO says, when we send our clothes out, a lot of the times when people open up the boxes of clothing, we ship them all over the world, people open up the boxes of clothing, when they take them out, the clothes are all falling apart. So we need to solve that problem. So Deming said, have you done anything about that? Here's what the trouble was. The CEO said, yes, there was one of these little dots right here, this out of control piece like on this slide that we have. CEO said, yes, we realized, wait a second, our clothes are falling apart because we're one of the factories that did not get damaged too badly in the war, and we just have old equipment. We need new equipment. We're good managers. Deming said, well, who was involved in that? And the CEO said, well, me and the executive group, we went up in the boardroom area up here and talked about this and decided new equipment. So we put all new equipment in. Deming said, yeah, I see that. It's nice equipment. Did that solve your problem? CEO said, nope, didn't solve it at all. Deming said, well, so then what did you do? Anything else? Well, yeah, of course we did. We realized, as the executive group again, sitting in the boardroom around the executive table there, said, wait a minute, how dumb could we be? We give people new equipment, we have to give them training. So we shut down the whole place for a few days and gave everybody training on the new equipment. Then we put them back to work. Deming said, did that fix things? No. CEO says, not at all. Deming said, well, what are you doing now? Are you doing anything about it now? CEO said, yes. We've realized that these people working here have been around here for a long time. We just need to get rid of all of them and bring in younger, newer, more trainable employees. So we're getting ready to bring a whole new group in. We're going to get rid of all these people and bring new people in. Deming said, wait, have you talked to anybody about what's going on besides the people in the boardroom, like any of the people sitting down there on the factory floor? And the CEO said, why would we do that? Deming said, let's go ask them. They went down the little stairs down to the factory floor and went up to the first person sitting in a sewing machine and said, hey, I understand your clothes fall apart. They do fall apart sometimes. They don't fall apart all the time, but once in a while they do. There are certain shipments we send out, they fall apart. Really? But most of the time they're pretty good? Yeah, most of the time they're pretty good. Do you have any idea why some of the clothes fall apart just occasionally? Of course we do. We all know why. Well, great. Tell me why. Okay. This sewing machine person says to Deming, we have a big warehouse full of old thread that we're trying to get rid of. So we use good new thread almost all the time, but occasionally they'll bring some of the old thread out here for 2 or 3 days to just try and use some of it up. So we have that old thread in here. We have some of that here right now. Look at this. Bing. That's not going to hold clothes together. I don't spend my day sewing clothes. I spend my day threading this machine all the time. This thread will never hold clothes together. We just need to get rid of all that old thread. We never need to use that. Pretty simple solution. It was an out-of-control element here, one of these pieces that a special cause. Once in a while, we were using the old thread, and those shipments of clothing were the ones that were falling apart. So again, looking at a simple chart where we just plot some data along the way here, and we find a special cause of a problem, instead of trying to change everything. Looking at this, say, clothes fall apart, we need new machines. You don't need new machines. You find out what's going on. Oh, it's only happening on these days. Why is it only happening on those days? Because those are the days we use this old thread. We stop using that old thread, we don't have the problem again, and we don't have those points that go outside of our control limits. So again, we're just looking at some data over time, and instead of just a simple run chart that shows how things move over time, what we're looking at is, oh, and we can mathematically calculate to say, should they be moving that much over time? We don't want to put our car cruise control on 60 and have that drive us anywhere between 45 and 80. That's not working. We want it different than that. We want some process in place that's going to keep us where it should be. This cruise control should somehow keep us between 58 and 62. You may have a car that keeps you somewhere between 59.5 and 60.5. And if that's what that car operates at, which you probably paid more money for that car, then that's great too. But we just know that it should never then go higher or lower than those numbers. Special cause of variation is what we've been talking about. And then there's common cause of variation. Common cause, just that every day there's just some little differences in what we do. Upper and lower control limits are what we're going to look at. This process is stable, it's working the way it should, and we don't need to go in and do anything at all about it. If we decide that, we know we don't want a cruise control that takes us between 58 and 62 miles an hour. We want a cruise control that takes us between 59 miles per hour and 60.5 miles per hour. We need to completely change this cruise control, put a different one in there, a new system. We have to change everything. So that's what we look at with common cause of variation. This process finds working within these limits. Well, those limits aren't good enough. We need to bring them in tighter. Okay, that's a whole process improvement issue, different than special cause of variation. There's one time thing happening weird someplace, we go deal with that one special thing. Common cause of variation and special cause of variation.